Alright, in this section here we're going to be applying some of that math we learned in the section on linear equations. And this particular problem here, which comes from my website that you can go to and click through. You can click through new problems, you get a random problem here. Alright, well, let's just look at this one here real quick. We got the length and width of a rectangular field is 96 feet by 48 feet respectively. What is the perimeter of the field? And I'll give you a hint down here. You can click on the hint button and you may actually see this differently. They actually may be listed over here, and that might say help. But anyway, so the perimeter, we got to remember, is equal to 2w plus 2l. Well, let's draw a picture so we can see what this looks like. Alright, well, let's draw a rectangular field. And how about that right there? Okay, looks good. I'm going to call this W and this side L. So this is W and L. And of course this may not be to scale from the numbers that we're going to use. Well, in the problem they said the W was 48 feet and L is 96 feet. Alright, leaving off the units. And we're asked to find the perimeter. Okay, so remember the perimeter was equal to 2W plus 2L, right? L plus W plus L plus W. Okay, this is considered to be the perimeter here. So all we do is just plug our numbers directly in. So we'd say P is equal to 2 times 48 plus 2 times 96, and of course we will get 288, and don't leave off the feet. And I went up here and hit answer, and that's what we got. Okay, let's look at another problem. I'm going to kind of thumb through here. See, the perimeter and width of a rectangular field is 82 feet, but what is the length of the field? Okay, this looks like a good one. Let's do this one. So remember, we're going to be using this equation right down here, or we can say the relationship between width, length, and perimeter. Okay, so we're saying that this is the width, and it is 5 feet. The length is what we're asking to find. We do question mark there. And the total perimeter, which I'll just label P, is actually 82 feet. So we want to find L. So we're going to say 82, which is P, is equal to 2 times 5 plus 2 times L, and we want to solve for L in this equation. Well, that should be simple enough. This is 82, and 2 times 5 is 10, plus 2L. So we're going to take the 10 over to the left, so it becomes 82 minus 10 because it's a positive 10. All right. And 82 minus 10 will be 72. And multiply both sides by a half. Got to get rid of this 2 somehow. And we have L is going to be equal to 144. So 144 feet. So let's go back up here. So we know that L is 144. Let's check that out on the website. Ooh, mistake. A half of 72 is 36. I don't know what I was thinking. Some of you out there are probably going, what? And I hit answer, and that's right. 36 feet. Cool. Alright, in this problem here, we're going to look at the relationship between Celsius and Fahrenheit. And I've got it written right down here. So this is an equation, a linear equation, because that's what this section is about. So we have the Fahrenheit is equal to 9/5 C times C plus 32. It's asking, let's convert 42 degrees Celsius to Fahrenheit. So let's go to the board. Let's remember this. 9/5 C plus 32. So we have Fahrenheit is equal to 9/5 times C plus 32. And we were given a Celsius and we wanted to convert it to Fahrenheit. So it was 42 degrees Celsius and want to convert it to Fahrenheit. Well, we just do the arithmetic here, and 5 does not go into 42, so we're going to have to do some multiplication. And what I do is I just go ahead and just plug it into my calculator. All right. And I believe I had 107.6 degrees Fahrenheit. And we clicked over here to the website, and that's what it says, 107.6 degrees Fahrenheit. Alright, let's find another one here. Okay, we already did that. Alright, let's take a look at this one. This is asking us to convert 16 degrees Fahrenheit to Celsius. And of course, here's the hint here. They've got Celsius, which is a function of F. And so let's go ahead and remember that. So we want to convert 16 degrees Fahrenheit to Celsius. So let me write that down so I don't forget it. 16 degrees Fahrenheit, and we want to convert that to Celsius. Okay, so let's say that we had, I'm going to actually start with what we did just a minute ago. Fahrenheit was equal to, it was 9/5 C plus 32. And we want to solve for C in this problem. Okay, so what I'm going to do is I'm going to take this 32 over to the other side. So we have F minus 32 9/5 C. And then I need to do something with this 9/5. Well, if I multiply both sides by 5/9, so 5/9 times this side and 5/9 times this side. I'm going to put a parentheses around this. Now, as you can see here, these guys are going to cancel out, and then we'll just be left with C is equal to 5/9 F minus 32. So if you can just remember one of them, then if you have to solve for C, you'll know how to do it. So now what we're going to do is just plug our number in. So you're just going to plug 16 into this. So 5/9 times 16 minus 32 is our C. So I'll let you do the arithmetic there. And once you've done the arithmetic, we're going to round here. I don't say, but I just round to 2 decimal places. Right, rounding 2 decimal places, and I got negative 8.89 degrees Celsius. Alright, in this one here, I kind of like these problems. This is find 3 consecutive even integers whose sum is 606. 3 consecutive even integers. Alright, so I'm going to help you out here. We've got I guess that's what my whole intentions are, is to help you out. To be an even integer, if I multiply a number by 2, that's going to guarantee that it's going to become an even integer. Okay, so remember what integers are. So 2 times the number, and if they're consecutive, then it'd be the next following even integer. And their sum is 606. So let 2x be the first even integer. And then the next even integer, we just add 2 to it. Right? Add 2 to it. And then the next one after that, we would add 4 to it. Right? Coming from this position here. Well, let's just write this out and work it out so you can see it. So remember, our sum was going to be 606. Alright, so the first even integer is 2x, and then the second even integer is going to be 2x plus 2, because we've got to come over a distance of 2, and then our third one, we would now be coming over 4. And that is all equal to 606. So what we want to do here is simplify this down and then solve for x. Well, let's collect like terms. 2x is a like term. So these are all like because they have x has a power of 1. So this is 2, 4, 6. This becomes 6x plus, then let's add our constants, 2 and 4, which is 6. And now we have an equation where we need to now solve for x. So taking this 6 over to the other side becomes 606 minus 6, and we have 6x. So this becomes 600. And now what we're going to do is multiply both sides by 1/6. And now we have x is equal to, so 1/6 of 600, right, so that would be 100 here. Alright, well let's see if this checks out. So 3 consecutive even integers that our sum is 606. So if I take the first one and I plug it in for x, and 100 times, or 2 times 100 is 200, plus, and then I do the same thing here, plugging 100 in for x, and 100 times 2 is 200, plus 2 is 202. And then I do it again here, plugging 100 in, that's 200, plus 4 is 204. So there are only 3 unique numbers that would sum to 606. So isn't that neat? Right, these are the only ones. There aren't any others. Okay, so 200 plus 202 is 402, and then plus 204 is going to end up being 606. 2, 4, 6, and then 4 plus 2 is 6. All right. So I find that pretty neat. And of course, let's check the answer. Yep, 200, 202, and 204. Let's look at another one. Alright, in this problem here we're going to be looking for 4 consecutive integers whose sum is 122. So let me go to the board. So our sum is equal to 122, and we're looking for 4 consecutive integers. So x is going to be our first integer, right? So that's our unknown integer. And then if we add 1 to it, that'll be our next integer. Adding 2 to it gives us our third integer, and then our fourth integer. So what we want to do here with this equation now is just simplify it down. So we're going to collect all our like terms, and because all our x's have a power of 1, that means that they're all like. And how many of them are there? There's 1, 2, 3, 4. So 4 x's. Now let's add our constants. We have a 1 plus 2 is 3, and 3 plus 3 is 6. And that is all going to equal 122. So now in this equation we want to solve for x. So I'm going to take this 6 over to the other side. So this becomes 122 minus 6, and we're just left with a 4x over here. So we take 122, we subtract 6 from it, and we get 116. We got to do something with this 4, and I'm going to multiply both sides by 1/4. And that's going to leave me with x is equal to 29. All right, well, let's see if this checks out. So if I were to say 29 is my first integer, add 1 to it, you get 30. Then add, right, you're adding another one to the 30 there. And so that's going to give me 31 and 32. And remember, that was all summing to 122. So let me plug this into the calculator here, or you can add that in your head if you want. And let me see what I get. And it checks out as 122. Okay, in this problem here, we're going to be working a simple interest problem. So let's actually go to the website. All right, so here's the problem. We've got Michael deposited $1,984 in an account paying 11% simple interest for 42 years. Yeah, 11% is pretty high, but just go with me on this. It's asked how much interest was paid out. So in this particular problem here, as you can see, I went up here and hit the hint. It says I is equal to PRT. So you're going to need to know what P is, what R is, and what T is up here in order to find out what I is going to end up being. So let's try to remember some of these numbers here. We got 1,984, 11% for 42 years. Okay, so Michael deposited, it was $1,984, right? So that's going to be the P. That's how much he put in the bank. And so that's going to be 1,984, and we won't, we'll leave off the cents here. All right, so that's our P. The rate was 11%. So R was equal to 11%, but we're going to move the decimal place over 2 places to the left. So that's going to end up becoming 0.11. And it was for 42 years. So T is 42. So we're going to leave that in years. All right, and this is all equal to I. So this is the interest. So what we're going to do here is just simply take this number and just multiply these 3 numbers together to get our final answer. And so how much interest did he earn? Ooh, it's a pretty good chunk of money, $9,166.08. Alright, let's go back to the website. And let's hit answer. 9,160. Oh, that's it. Alright, let's look at another one quickly. Okay, sorry, I had switch problems there. Okay, we've got Mitt deposited $8,073 in an account paying 7% simple interest. The amount of interest paid out was $54,250.56. How long was the money in the account? Okay, so we're going to go back to the same formula this time. So that formula we're going to use, calculate the interest, is the principal, whoops, well, it doesn't matter what order I put this in. Oh my goodness. Okay, interest, let's go ahead and erase that stuff, is, might as well just put it in the same order. Rate times time. So in this particular case here, we're asking to solve for time in this problem. So what I'm going to do is I'm going to get time by itself, and that means I'm going to multiply both sides by 1 over p times r. That would be 1 over p times r right here. So as you can see, those cancel out, right? And so we're left with I over p times r is equal to t. Whoops. Okay, so I just went ahead and wrote it out here. What the principal is, the rate and the interest. Now the rate was 7%. Remember, we move our decimal place over 2 places to the left. So you go ahead, substitute these guys in, and see what you get for t. And we're going to come back to the website and see what the answer is. So hopefully you get 96 years. Alright, let's see what we got going on here in this problem. We got the height of a box is 3 feet and the length is 14 feet. The width is 3 times the length. Find the volume of the box. Alright, so there's going to be a formula that we're going to use. Alright, I got to remember these numbers here. We got 3 feet and 4 feet, 14 feet. Okay, so I've kind of sketched out a box here. Not exactly the best sketch ever. And we're looking to find the volume. So we've got volume is equal to length times width times height. Now they give us a couple of these numbers and then they give us a relationship. Okay, they say that the, let's just write down what they give us. The height of the box is 3 feet and that the length is 14 feet and the width is, that would be equals, the width is 3 times the length. So these are the things they give us, and of course this is the formula here that we're going to use. Alright, so the height is 3 feet, so this, we'll say this is 3 feet from here to here. Okay, good enough. The length is 14 and the width is 3 times the length. Well, it looks like another one of my drawings here is not quite to scale. But we're going to let this down. We're going to let this side here be the length. Okay? And we're going to let this side here be the width. And so the width is what we don't know. But we've got a relationship between the width and the length. And that is that the width is 3 times the length. So what we can do here is to say width is equal to 3 times 14 and then get that number. Okay, so that's going to be 42. Now, all we're going to do here now is we've got the height, the length, and now we have the width, and we can just simply plug it right on into our formula. And I think I'm going to squeeze that in right here, and I'm going to use a different color. So the volume is equal to the length, which is 14, times the width, which we said was 42, times, and the height, which is 3. Right, so you can plug that into your calculator and get that number. So I get 1,764, and because everything was in feet here, this is going to end up being cubic feet. Alright, so that's cubic feet there. Okay. And of course I had to go to the problem here, make sure I did it right. 1,764 cubic feet. Now I write out cubic feet here, but if you put a little 3 above the FT, that's the same thing. Alright, let's look at another one here. We've got 25 more than 46 times a number is 1125. What is the number? So the number, we're going to let that be x is the unknown, and then we're just going to write out an equation, just pretty much how it says here. 25 more than 46 times a number. So 46 times a number. So let's goodness. Let's go back to this. 46 times our number is unknown, and that was 25 more than, so we're just adding 25 to it, is equal to 1129. So in this problem here, you're just going to simply solve for x, and you should know how to do that up to this point. So 1129, bring the 25 over, right, and then divide by 46. So I'm starting to skip steps now, hoping you can get that. So plug that in, and that should be your answer right there. Alright, this problem here is going to be a doozy. Okay, we got find 4 integers whose sum is 62,046, such that the second integer is 9 more than 17 times the first, and the third integer is the sum of the first two. The fourth integer is 16 times the third integer. Man, that sounds complicated. Okay, I think I came up with this one a couple months ago. Alright, where do we even start at? Let's go to the whiteboard. Alright, so we're looking for the sum of 4 integers. So I'm going to call the first integer x of 1. How's that? And the second integer x of 2, x of 3, and x of 4. And then when we add them all together, we get this nice number here. 046. You can throw a comma in there if you want. Alright, now the second integer, how it's going to be related to the first integer is that the second integer, that would be this one here, is actually equal to, it said 9 more than 17 times the first integer, but the way I'm going to write this is 17 times the first integer, and then we throw the 9 on the end. It's 9 more than 17 times the first integer. Alright, the third integer, x of 3, is the sum of the first two. So we could say that it's the sum of x of 1 and x of 2. Right, the sum of both of them. And the fourth integer, let's find that relationship, is 16 times the third integer. So that would be 16 times x of 3. Whoops. X of 3, not 6. Alright. Now what we're going to do is just plug this stuff directly into this up here. So I just rewrite the first integer, which is x of 1, plus the second integer, which we said was 17 times x of 1 plus 9. 17 times x of 1 plus 9 plus, now what we're really wanting to do here is we're wanting to get this thing all in terms of only one of the variables, and it looks like x of 1 at this point. Alright, let's see. So we got the first integer. This is the second integer. The third integer is x of 1 plus x of 2, and then the fourth integer is going to be 16 times x of 3. But we still need to get this thing all in terms of x of 1. So we remember we can now substitute in for x of 2 here, because x of 2 is 17 times x of 1 plus 9. So we can put 17. Actually, before I do that, I'm going to simplify this down and collect up my like terms. Okay, I simplified this down as much as I could. Remember what all this was equal to was that sum, a big number. Now I'm going to go ahead and substitute in for x of 2 and then in for x of 3. Okay, so you should have gotten this far. X of 2 is this, and then x of 3 is this here. Now we got to substitute in for x of 2 again. However, before I did that, I distributed the 16 across first. Well, I simplified this down as much as I could. Now we got to distribute this 16 across inside. Alright, we substitute or distributed across, we simplified it down. Now what you need to do is solve for x of 1. Once you've solved for x of 1, these are the number. This is x of 1 here, and then you can determine what these others are.